In this video, we'll go over breadth first search. The algorithm is given here. It uses a queue data structure as well as a set. The algorithm receives a starting node. In our case, it will be node A as a starting node. The algorithm starts by placing this starting node A, pushing it into the frontier queue, and then also placing it into the discovered set. And then it goes through this while loop. As long as the frontier queue is not empty, it isn't right now, A is in there, you're going to pop the element A from the frontier queue and place it as the current vertex. And then also do a visit. By visit, it could mean anything, some computation, or perhaps just printing the node. In our case, we'll just print it. That's what it means by visiting it, basically. And then we go through this for loop. In the for loop, we'll look at all the adjacent vertices of the current V. So we'll look at all the vertices adjacent to A. It is D and B. And if D and B are not in the discovered set, we'll push those adjacent vectors into the frontier queue as well as add them to the discovered set. So the adjacent node to A is D. D is not in the discovered set, so we'll place it in the frontier queue as well as discovered set. We'll do all of those basically, and then go to the next adjacent node. In this case, it will be B. B also is not in the discovered set, so we'll add it to the frontier queue as well as discovered set. So we are done with this for loop. We go back to the top of the loop. Queue is not empty. What we do, we pop an element out of it. The element, let's say D, is popped out of the queue basically, and that element is placed as current V. We are going to visit this node by printing it. And then for each node adjacent to D. Adjacent to D, we only have one node, and that's A. And if this A is not in the discovered set, but A is in the discovered set already, so the if statement will not execute. We go back to the top of the loop. We look at the frontier queue. It has element B in there. We pop it. We place that element in as current V. Next, we look at all the nodes adjacent to B. What are the nodes adjacent to B? We basically notice that A, E, and F are adjacent to B. A is already in the discovered set. E is not in the discovered set. F is not in the discovered set. So what we do, we add them to the frontier queue as well as the discovered set, both E and F. So the for loop is over. We'll go back to the top of the loop, and when the current vector was B, I think I forgot to visit it as well. Let me just visit that vector B as well. Now we go back to the top of the loop, the while loop, pop an element from the frontier queue, and that would be E. We'll pop it, we'll place it in the current V, visit it, and then look at the nodes adjacent to E. What are the nodes adjacent to E? B and F. B is already in the discovered set. F is already in the discovered set, so the conditional statement will not execute. So we go back to the top of the loop. Frontier queue has F in it. We'll pop it and place it in the current V. We visit the vertex F and then look at the nodes adjacent to it. B is adjacent to F, E is adjacent to F and C is adjacent to F. B is already in the discovered set, E is already in the discovered set, but C isn't. So what we do, we push C into frontier Q and also add it to the discovered set. You go back to the top of the loop, while loop, frontier Q is still not empty. We pop it, place it as the current V, and then look at all the nodes adjacent. We visit it. I forgot to mention that, so we'll visit it. There's C. And then we'll look at all the adjacent node to C. In this case, it's only F. F is in the discovered set. The if statement is not executed. You go back to the top of the while loop. Frontier Q is empty, and we are done. And basically, the nodes have been traversed using breadth first search. Now, how is it traversing this graph? It starts by A, then visiting D, then visiting B, then visiting E, then visiting F, then visiting C.